So in this video, we're going to be talking about 1.1.2 in our textbook, and this is for the 1015 class. Now, this one is very short. We'll try to get through it quickly. But basically what 1.1.2 is talking about is what is a function and what is not a function, and then how would we write out what functions would look like. So when we're talking about a function must have one output for every input. Or I guess it's the other way around. One input for every output. One moment. Yeah, so you can't have more than one output for every one input. So say we have this circle here. This circle is not a function. And a way that we can tell if it's a function or not is to do a vertical line test. Now that's to say we're going to draw a line straight up and down, and if it hits more than one point on our graph, it is not a function. If it was a graph like this, we could draw a vertical line and it would only hit on one point in our graph. So we cannot have two outputs for one input. We have to have one output for one input. If you had a graph that was sort of like a U here, it still passes our vertical line test. So this is still a function. Later on in this unit, we'll be talking, in this chapter, we talk about one-to-one functions. And that is a function that is a function, so it passes the vertical line test, but it also passes the horizontal line test. This one is not a one-to-one function, but it is a function. And this is neither a function or a one-to-one function because it passes neither line test. So in this case, these inputs all have one output. So this is a function. It would work. This one's being kind of tricky. This input has two outputs, and that means it is not a function. That does not work. This one, we have to see which things we have. All of these inputs are different, and all of these outputs are different, so it's a function. As long as all the outputs, we'll get into that. This one is giving us a ordered set of pairs. We say, okay, we don't have any repeating inputs, so it's fine. We have a function. This one tried to trick me at first because I saw the 5 and the -5 and I forgot about the negative. So this one is a function. When we're talking about the inverse of a function, we're basically saying we're flipping the x and the y's. So in this case, we'll say this coordinate pair is going to be 5, -5. This coordinate pair is going to be -2, -5, and so on. You're basically flipping the x and y values. This one is saying a one-to-one function has a domain of -infinity to +infinity and a range of -infinity to 4. State the domain and range of the inverse function. Now, what we said before, where we flip it, it's kind of a little bit different here. We are still flipping, except for we aren't flipping the individual things. We're saying now this domain is actually going to be our range. So -infinity to 4, and close bracket there. And then our range is going to be -infinity, +infinity. So we don't flip the insides, but we flip what our domain is and our range is. If f is a function, so this here is talking about making functions with like word problems. If f is a function that when applied to any domain element x says add 2 to any real number, we want to write that in. So it sounds really confusing and hard to parse through at first, but it's more simple than it might look. So it's saying add 2 to any real number. So in function notation, we do f of x. Now, f of x is exactly the same as y. So you could write like f of x equals x plus 1, and you could write y equals x plus 1. These are exactly the same. That can sometimes scare students. They think that you can solve for x somehow by like dividing by f or something. You don't need to do that. Just and it can be h of x. It can be anything with of x, and that will be our function. So when you're, and then a side note, when you are working with inverses of functions, you'll do f, and then it'll say to the -1 and then of x. And then, but that's a side note. So we have we're adding 2 to any real number. So we'll have any real number plus 2, and that will be our function. If 1 is in the domain, now remember domain typically means x, or our inputs of f, what value does it map to in the range of f? So basically we're going to plug in 1 for f. So 1 plus 2, that is 3. Easy math. If 4 is in the domain of the inverse of f, what value does it map to in the range of f of -1? Not f of -1, the inverse of f. So basically we're saying if we have 4 as, in this case it'd be as our y, right here, our f of x, but in our inverse, it's going to be different. So we're saying 4 equals x plus 2. We can minus 2 from both sides. Then we'll get 2 equals x. So that is our case for our original function, but it's not the case for our inverse function. In the case of our inverse function, this actually turns into y, because we flip the y value, right? So our value it maps to in the range would be 2. And yeah, I get that this one deals a lot with like English and wordy problems, and it can get really confusing with all the technical language that it uses. If you have any questions, please let me know and I'll answer them as soon as possible. Have a good one.